Refractory industry in a very baby stage. Now we are talking of producing 300 million tons of steel in next 5 to 6 years. That means we are going to double our steel production capacity. Without producing steel, probably we cannot grow as a nation. 30 years back, China was a undeveloped country, and today they produce 70% of the world steel. Unfortunately, in India, we talk of the institutes, the universities. I have not seen any development in refractory technology, and no technology transfer is there from Indian universities to the industries. All over the world, except China, in the industry level. In China, the situation is entirely different. The government develops the technology, they pass on to the industry, and they get a royalty for this. So technology is very stable. Indian refractory industry, we are in a cat race. We just try to supply something at a cheaper price, and we fool ourselves as a country. See, basically, you see, my paper, the synthetic aluminum aggregate, this is a very interesting paper because you talk to any ceramist, they will talk of mullite. But what mullite? What is the level of impurity? How does it contribute? What is the mullite content? What is the amount of glassy phase? If I make a brick out of it, what is the creep value? I have worked with various research institutes in close collaboration, and I find the creep of all the manufacturers, including the bricks that is being imported to the country, they fail in the creep. That means basically you are trying to intentionally or unintentionally trying to develop a product which has got a lot of impurities. So now when India is thinking of producing 300 million tons of steel, and glass is not far behind. Glass plants also, they are growing, and mullite is a very favored refractory item for glass industry particularly. So, but when we talk of mullite, we can categorize the mullite because mullite is one phase. So we have mullite, say principal phase, 70%, 80%, 90%, 95%. But what is products in alumina range as well as in basic products also to glass industry, we are doing it for last 10 years. And we have faced all this problem. We want to solve the problem. So basically we want to develop mullite and supply products with zero creep value. That means the glassy phase should be minimum. That means the mullite phase should be more than 85 to 90%, and the rest should be corundum phase. That means it should be grain to grain bonding, no liquid phase bonding. So mullite, one of the most widely used refractory for glass, steel and ceramics, and other applications will be 3 times in next few years. So when the steel will be 3 times higher growth than the present level, what we have to do for refractory? Will the refractory also grow 3 times? If that is the case, can we produce 3 times the volume of steel we produce? It will not be the case. So the refractory should perform at least 1.5 times than what it is performing today. If that growth is 3x, refractory performance should be at least 1.5x or even more than that. So basically, when you talk of mullite, because when you talk of glass industry, where the present life, they desire 12 years, 15 years, 20 years like that. When you talk of blast furnace, when the life is now 15 years, 20 years. So we require refractory, we also should perform that much, with minimum risk. As a joint venture to produce this one. So the property of the new aggregate will be something like this, but we have developed. Here you can see the impurity is 0.25% only. This is because we have started with calcined alumina. If we start making with, say reactive alumina or 99.8% alumina, the impurity will further come down. The porosity here is 2.9% because that is acceptable limit, but it is possible to get maybe 0.1 or 0.2% porosity also. That product will be equal to like a pure mullite. And mullite phase here is 89%, because we have added more alumina, because we don't want any silica, free silica in the body. If we control the corundum phase, we can increase the mullite phase further. So this is the microstructure we have developed for this. It has got only mullite and corundum and nothing else. And this is the XRT study quantitative we have done to achieve the figure of 89% mullite phase and 11% corundum phase. And this is the brick we have developed up to. So here you can see that the creep at 1550 is 0 and it's at 1600 it is 0.02%. So this product is required very much for Indian industry. If we have to really achieve the level of steel we want to produce or the level of glass we want to produce, and if we want to stop importing refractory to the country. So that's all. Anything, anybody?